Okay, so let's share the screen here. Okay, so one thing you should be able to do by the end of this unit is just identify polynomials based on their graphs and their equations, and then just answer some questions about them. So in this question here, they are asking you to match the 4 graphs with the 4 equations given below. Hopefully you can read them. Maybe I'll write them out. So the first one, A, is a function to the power of 4, and B is a function to the power of 3, and then C is power of 4, and then D is power 3. Okay, so those are the 4, a little bit hard to read. Okay, so one thing you should remember is that odd degrees have ends in opposite direction, and even degrees have ends in the same direction. Okay, so those are 2 things that will help us identify these graphs. Also, the difference between positive and negative leading coefficients. Right, positives go up, negatives go down, and then that should help us to kind of narrow this down. So when I'm looking at maybe the power 3s, so B and D are both power 3, I would look at the graph and I would expect the graphs to be having ends in the opposite direction. So that would be graph A and graph B. And then if I want to distinguish between those 2, one's going uphill, right? This one's going uphill from left to right, and this one's going down from left to right. So when I look at these graphs, I see that B has a positive leading coefficient. There's a 1 there. And then D has a negative, right? There's a negative here. So let me fix this a little bit. So D has this negative leading coefficient. So this one, D should be going down, so this one must be D, and B is going up, so this one must be B. Okay? If it is power 4, which is an even degree, then I'm looking at positive or negative leading coefficients. Well, C and D graphs both are going up. So they both have a positive leading coefficient, and they both are even degrees. So then I might say, okay, well, let's find a point. If I look at C, and I just sub in 0 for x, that's an easy point to find. I see I get 3. So C has to go through 0, 3, which would be this one. So that must be C, which making this one A. Okay, so I need to get those information to allow me to kind of narrow down which is which. This one is similar. For each graph, determine the sign of the leading coefficient, the x-intercepts, and we're not going to write the equation, but we could determine the degree. So let's just put the degree. Okay, so graph A, it wants me to find the sign while it's going uphill. So I know that it is a positive leading coefficient. The ends are in the opposite direction, right? One is in quadrant 3, the end is in quadrant 1, so it's going to be an odd degree. And then I might look at how many times it turns. So it turns once here, once here, once here. So 3 turns, but it's got to be at least 4, but it can't be 4 because it's odd, so I'd say it's probably minimum 5. Okay, because I have a turn here that is an extra root. I'm just going to verify this. This smartboard's a little off. Okay, B is, when I look at B, I know it's got a negative leading coefficient because going downhill, right? It's starting in 2 and ending in 4. So it's going to have a negative leading coefficient. The ends are going in opposite directions, so I know it's an odd degree. And it's turning twice, so I know it's minimum power 3, right? It's always one less, so it's minimum one less than the number of turns. And then the last one also has a negative leading coefficient because it's headed down. The ends are going in the same direction, quadrant 3 to quadrant 4, so it must be an even degree. And it's got 1, 2, 3 turns, so it must be at least minimum power 4. So those are the information you should be able to find from just a graph, determining degree, leading coefficient, and power. Okay, what else is here? Okay, so here is maybe they don't give you a graph, they give you an equation. Same thing. What's the degree? What's the sign of the leading coefficient? And then determine what the end behavior is. So when I look at this, the degree is the highest power, so it's degree 3. Right, you can see that there. The coefficient on that is positive 1, so it's a positive leading coefficient. And then the end behavior, well, the ends have to go in opposite direction, and it has to go uphill. So it must start here and end here. Okay, it doesn't really matter what it looks like. I just know that it has to go uphill, and it has to start at the bottom and end at the top. So it must start in quadrant 3 and end in quadrant 1. The next one, here's the highest degree. So it has a degree 4. It has a negative leading coefficient. And the ends, well, it has to have ends in the same direction, and they both have to go down. So it would have to start in quadrant 3 and end in quadrant 4. When you're determining end behavior, but you're not asked to sketch it, it doesn't really matter what it looks like. You just have to know whether it's going up or down, and whether it's going in the opposite direction or the same direction to determine that end behavior. Okay, and then we did, so that was quite a bit of the guide. And then we did some applications with finding the maximum, the minimum, and the roots. So here's a typical quadratic equation where you have the height of a diver in terms of time t. So time is in seconds, and the height of the diver is in meters. So the question says, what is the maximum depth reached by the diver, and how long does it take to reach that depth? Okay, so if we're going to find maximum or minimum, we can use our short version, negative b over 2a. Easy way to find the vertex. So in this case, b is negative 15 and a is 3.75. So remember, if it's in standard form, it's ax squared plus bx plus c. And then we'll just put that into the calculator, and it works out to be 2. So that actually answers question B, or part B. How long does it take to reach the depth of the maximum? It takes 2 seconds. If I want to find the actual max depth, I'm just going to put this value back into the equation. And that will give me the maximum depth, which works out to be negative 5 meters. So why is it negative? Well, because he's diving down. Think of the water, and it's a parabola that, so let's say this is the water. It's a parabola that opens up, so he's diving down and coming back up. So this is the maximum depth, right? So it occurs at 2 seconds. He reaches a maximum depth of 5 meters, and it's negative because it's below the water level. Okay, so that makes sense with that. Okay, this one we didn't really look at, but this is a typical, and I think there was a question in the guide on revenue. And you probably looked at it in grade 11. We do it quite a bit in grade 11. So remember that revenue, when you make money, you have to sell something. Right, so we're going to sell some sort of item, and we're going to make money depending on what price we sell it at. Okay, so in this case, at the concert, they sold 20,000 tickets for $100. So originally the revenue was 20,000 tickets at $100 each. Right, so the original, let's look at what the original revenue was. So the original revenue was $2 million. Okay, 20,000 times 100 is $2 million. But they're going to change the ticket price. So they're going to put the ticket price down by $10, and then 5,000 more people would go if they put the price down. So the new revenue, so whenever we do these revenue questions, we always start with the original number and the original price. So this is number of tickets, and this is price. And then we say, well, what are we doing with the price? We're reducing it, so minus $10, and that means 5,000 more people would come. And then we put X, so X represents how many times we're going to do that. Okay, that's what your variable is representing. How many times am I going to change the price? Okay, so what we want to do is expand this, these brackets. I'm going to just multiply them together. And then I'll just collect like terms. I'm going to put the x squared at the beginning. So it's in descending order. I'll add the two middle terms together. And we have 2. And now we want to solve for the maximum, right? Because we want to find the maximum revenue. So we can use our short version, negative b over 2a. We don't have to complete the square. We can just put in the numbers. And a is negative 50. Okay, and we'll work that out for x, and it works out to be 3. So what does that tell me? That tells me I'm going to change the ticket price 3 times. Right, that's what that means. So it wants to know the new price. So the new price would be the old price, and we were dropping it by $10, and we're going to do that 3 times. So the new price is going to be $70. How many tickets am I going to sell? Well, I was selling 20,000 tickets, and we said 5,000 more people would go, and that's going to happen 3 times, right? Because x is 3. And let's see what that works out to be. So that's 35,000 people will now go to the concert. And so if I wanted to figure out my new revenue, I would just say, well, now I'm selling 35,000 tickets at $70. So I'm selling them for less, but I have more people going. And so now my profit is 2,450,000. Okay, so that would be my maximum revenue. You don't want to put the ticket too low because you're going to lose money. Okay, so you want to get that balance. So if you were graphing it, you've got revenue, right? So you've got number, you've got your price and your revenue, And there's going to be that price where you're going to get the most people going to make the most amount of money. Okay, and that's probably familiar from 3U or 3M. We did some revenue questions there. And then this is the last one. So this is a rocket, typical projectile question. The height of the rocket is given. So that's the height of the rocket. The rocket is the rocket looks something like this, right? It's a projectile, so it's going to go up and hit the ground. So it wants us to A, find the height at 10 seconds. So all we have to do is plug that amount into the equation, find it at 10 seconds, and then we'll just find the height. Need that. So just a matter of plugging it into the calculator, and it works out to be 1,000 meters. Okay, B says, what time will the rocket return to the ground? So you have to ask yourself, well, what part of the equation am I trying to find? Right, well, I'm trying to find when it hits the ground. So I'm trying to find the x-intercepts, right? That's what I'm trying to find. So how do I find the x-intercepts? Well, I use the quadratic formula. If I can't factor, you would use the quadratic formula. All right, so it's just a matter of plugging these numbers into this equation, and we are going to get two answers. Just be careful of signs. Okay, so I'm going to get, I'll just simplify the value in the square roots. If we multiply those numbers together, we get 109600. So don't forget, you've got 3 negatives there. Okay, so I'm going to get two solutions. I'm going to get negative 398 plus the square roots. And then I'm going to get negative 398 minus the square roots. So you'll always get two solutions. One of them is going to make sense and the other one's not. So it wants to know where it hits the ground. So my first solution works out to be 6.83 seconds. And the second solution works out to be 74.4 seconds. So when I look at my projectile, well, I know it's going to come up and go back down. So the route I want is this one, right? So this one is going to be the solution at 74.4 seconds. The first one is where it goes up the first time, right? Because it's not starting, if I look at my equation, it's not starting at 0. It's starting at negative 2490. So that's down here. So it's coming up and coming back down. And then C says, at what times will the rocket attain a height of 4,000? So that one, is that D? So here's my formula. So it wants to know when the height is 4,000. So I'm going to put in 4,000 for height. So again, let's look at the projectile. So we have this rocket that's coming up and back down, right? So this point was where it starts. So it wants a height of 4,000. Right, so it wants, where does it hit 4,000 on the way up? where does it hit 4,000 on the way down? So you're going to have two solutions. So in order to solve, it has to equal 0. So you're going to have to move the 4,000 to the right side. And add it or subtract it from here, right? So it has to be, everything has to equal 0. So that would be 6,490. And then you're going to use your quadratic formula again. Right, so then we can solve again. So basically we've moved, by putting the 4,000 in and moving it to the other side, we've basically moved this x-axis where we normally solve, we moved it up to 4,000 meters. And so we're solving for those two values. And if you type in those numbers into the formula, you end up with two answers. So that would be on the way up at 22.5 seconds, and then you would have a solution on the way down would be at 58. So once on the way up, once on the way down. Okay? And then the last question, so the projectiles usually have quite a few things they can ask you. So what's the initial time? When does it hit the ground? When does it get its maximum height? How long does it take? Right? There's lots of things you can ask. So D says, what is the rocket's maximum height? So this was actually C. So D wants us to find maximum height. So we can use our negative b over 2a. So now we're looking for this point, right? This point in the graph. What's the maximum height? So we'll just put in our numbers here. B is negative, well, B is 398, and A is negative 4.9. And that works out to be 40.65. So at 40.65 seconds, right, that's when it hits, oops, it's a little bit off again. So that's when it hits the maximum height at that time. So you'll need to find the height. So we've determined the time that the height occurs, but now we need to find the actual maximum height, and we can do that by just subbing that value back into the equation. So we'll do height, and then we know it occurs at 40.65 seconds. And that height works out to be 5591.8 meters. Okay. So lots of things you can ask with a projectile question. Maximum height, when does it hit the ground, how high was it when it started, what's the height after a certain time, lots of things you can ask there. So those are applications for max min. There are some in the guide that you can work on. They're not as nice as these ones. I picked some questions that the answers are pretty reasonable to find. But just as long as you know how to find the maximum height, and then also using the quadratic formula to find, to solve. Okay, I am just going to mute myself for a second and do the attendance.